Hi, good evening, everyone. So today we are going to discuss about how we can find a denial of service attack, and especially when we get some kind of SYN attack, TCP SYN attack. So how exactly we can find that with the help of Wireshark. We'll look at that. Then followed by that, we will have a discussion about what is QoS and what is the different classification of QoS, and how Wireshark is going to interpret those QoS packets. And when we use OSPF, and what is default QoS bit that has been assigned for OSPF, and we will do a lab for the same. And in addition to that, we'll see how this TCP flow graph helps us to find the communication between source and destination, and what are the key values we can look at when we are doing troubleshooting. And it will give a complete visual of what exactly happening, and something like if it is a TCP connection, it is a 4-tuple connection, you see that. And if it comes to routing protocols, you see who is sending hello packets. And on top of that, you also see and from the OSPF perspective, you see link state, database update, LSU, all your LS informations. I mean, you can see the bidirectional flow between source and destination. You have an option for it, so you can leverage it for your troubleshooting. There's one not only for one specific protocol. And when you talk about EIGRP, there you will see what exactly it's been exchanged, and what is the flow between source and destination. That's kind of giving more visuals. So example, if from point A to point B, if I'm keep sending hellos, and if I'm not receiving hellos, so you can go ahead and see that in the TCP flow graphs. And it could be a very helpful when you do a troubleshooting. It would be helpful for you to isolate and to get started with where exactly the problem is residing. And followed by that, we see an option, what is protocol hierarchy in Wireshark. So that will give you a complete insight of what's going on in your box. It can be a firewall, it can be a router, switches. So it will give the protocol information, something like, okay, my protocol is active, and who is the top protocol in my in my router, or maybe your appliances, whatever you're running on. But before going to this DDoS attack, the prerequisite is you should have this geo maxmind database that should be integrated. In the previous classes, we discussed about that, how to integrate the geo maxmind. So you should have the database that's going to expose the information, something like where exactly the traffic is coming from, who is the originator of this traffic, where it is coming from, which country, and which part of the country it's coming from, and what is the ASN number. So what kind of public IP they have, and whom they are. So it gives a complete detail about where exactly the traffic is coming from, and is it a legitimate traffic or not. So when we discuss about this, so I want to give you a little bit of background, a quick refresh about TCP. We're not going too deep about TCP, just for the SYN. So this is important to understand. So if you got a different location, example, this is an US and this is an UK, and it can be Japan, and this can be in India. So we all know that the ocean cables are running under the water, under the ocean seas, and it's connecting the different part of the country. So this is how it happens. And in the middle, we got many routers in the middle. So it is not just one hop away from my source to destination. So from from the OSI model's perspective, so from the layered approach, when we do troubleshooting, so if something like, if I say this is TCP's SYN attack, So here is a user. So he's using Nmap, and he's trying to hit my public IP address with continuous scans. So he's doing a SYN attack. So it is something like he's generating a traffic, not Nmap exactly. It does a scanning. So he's using some kind of Kali Linux, some kind of tool, hacking tool, where he's trying to generate the SYN attack continuously to my box, to my router. So, how Wireshark helps to figure out this? So it's all based on the logics. It helps. Okay, the origin of the traffic is from US, and the TTL, the maximum TTL, it should not exceed more than 30 hops. So across the country, that's some kind of a limitation we have, right? So if the traffic is coming from US, and if the TTL is something 62, so it's looking a little weird, right? So because if the traffic is originated from, so if it is 62, it has to start with 64. So if it is decremented, it cannot be definitely a 2-hop away to my destination, because I am from India and we have many devices in the middle. And the reasonable consideration can be a 15-hop, a 16-hop, that makes sense. But if my TTL is very less, I mean, the TTL value is something, it resembles a very odd value, then that is something I have to look at. So even though it is a TCP connection, it's a TCP SYN attack, so we have to focus on the TTL. So TTL is a very important parameter in Wireshark. So you have to apply the logic both from network layer as well as from the TCP layer, and what exactly the TTL it makes sounds. I mean, if it sounds legitimate, it's fine. And if the TTL, it doesn't make sense because the traffic is coming from somewhere from the world, so I mean from a specific country, and the TTL value is too minimum, and that's something not actually justified to be a legitimate connection, right? So that's how we have to, you have to correlate the TTL value with TCP SYN attacks. So let's see how Wireshark is going to, how with the help of Wireshark, how we can leverage this even more, and we can spot exactly where the traffic is coming from. Is it a legitimate traffic or not? Yeah. So let me fire up the Wireshark for it. So if you see, this is a capture. This is a test capture. So I'm getting a lot of TCP SYNs here. So without the max bind database, this is something I couldn't find where it is coming from. So I think in the early classes, we have discussed about this name resolution. This is very important. You have to go to preferences, and you have to go to name resolution, and you have to enable use capture DNS packet data for name resolution, use your system DNS setting for name resolution. And if you're in your enterprise network, I would always suggest you to edit this, and you should add your local DNS here. It's an UDP port 53, so you can add your DNS resolvers. That is the one which holds your DNS records. All your DNS resolvers address should be added here, not your name servers. So you can add it. So if you have a load balancing DNS servers, you can add multiple servers. You have an option here. So here exactly you can add your DNS servers. So when you click on it, so you get a value for IP address, and what is the UDP port? It is 53. So that helps us. If you look at this, you can see it's been resolving, right? So it's something like it says reverse.superonline.net. So I come to know about domain, which domain it's coming from. So I see a lot of SYN from the super online. And if I scroll up, so I see a lot of SYN. So this is definitely not a normal behavior here. That is something looks like abnormal, but how I can differentiate it. So if I just click on one particular packet here, I have to go inside my layer 3, and I have to go inside this. So it's the traffic coming from Turkey here. So all I have to do is I have to click on this source geo IP country, and I have to drag it, and I have to apply this as a filter here. So I see a lot of SYN, but I'm not sending is SYN ACK response. The other key thing you have to keep an eye on. I mean, you have to be careful, and you should keep an eye on it. That is in the modern TCP. I mean, when the SYN establishment happens between source and destination, it should share the TCP options here. If you look at this header size is 20 bytes, and I don't see any TCP options. We discussed about the TCP option is, so do I agree on selective acknowledgements? So that is very important. So it is not sharing any kind of TCP option. So definitely this is a scan. Then you have to go to statistics, and you have to go to conversation. And I'm sorry for it. So we have to go to statistics endpoints. So let me take out this. Okay. This is all public IPs. So I should see the AS number only for public IPs, right? So I think the traffic is coming from private IPs. Okay, so here I see traffic, it's coming from this Alfie, and you see the ASN number, it's pretty same, and it's keep trying to establish a connection with me. And if I open the map, if you see here, I see this particular source. I mean, from this particular ASN, I get a lot of hits, right? So it's all scans. So a legitimate connection cannot be this many connections from this destination. So what I'm saying is that this is not specific to TCP SYN, but I see a lot of traffic that's been coming from this particular subnet. So this is one trace file. This is captured for the scan. And so we'll get an insight, right? So why do I see a lot of traffic that's coming from here? So if I look at this is 739 connections. So this MaxMind database is pretty helpful for you to figure out, is it some kind of DDoS attack is happening? So you can you can leverage your learning with other protocols. But for this TCP SYN attack, if you look at this, I see a lot of SYN, and my destination is not responding back to it. So that's the takeaway of it. So this is how with the help of MaxMind database, you can figure out where exactly the problem is. And one thing we discussed about, if you see this, this particular country, if you look at this country, let's go to this is Turkey. So if I apply this as a filter, and if I look at this is 123, TTLS 123. So the TTLS 123. So if it started from 128, so from Turkey to my location, it cannot be definitely 123. So it means that it is just 5 hops away. That really doesn't make any sense. So this is spoof packet. It's someone is spoofing. You got it right. So the traffic is not actually coming from Turkey. If you look at this shows this as a public IP address. And if I go down here, what is the country I see here? This is again a Turkey. So a public IP with 255. So how many hops? So 5 plus 7. So 13 hops away. So this makes sense. But all this 123, so it can be definitely, it cannot be, this might be a legitimate traffic here. And if you compare the IP header, this is something 212.252.18.251. This is something I suspect this could be a problem with. This is a flood attack, TCP's SYN flood attack. So I have to keep eye on this particular public IP address. So I have to blacklist this IP address inside your enterprise network, wherever you have an option. So you have to blacklist this IP address. So you should not allow, if you have a firewall, you have to deny all kind of connection to this. So this is how you can figure out. So with the help of TTL and with the help of MaxMind database, you can actually find your abnormal scans that's coming from a different location. So the next topic we're going to discuss is QoS. So let me open up this whiteboard for the same. So why I need QoS? That's the biggest question everywhere. So why I need QoS? So without QoS, so what is the impact of if I am not configured QoS anywhere on my environment, or maybe in my company, if I haven't applied QoS and I don't have this QoS feature exactly on the appliance, what would be the impact? So we talked about network packet loss, network congestion, network performance, so the very good design should be something like this. If I got a small switch, some kind of layer 2 switch, and this is my edge device. So here I got multiple PCs connected here. So if you think from the SD-WAN perspective, so SD-WAN is next generation of MPLS, right? But the greatest advantage what I have with MPLS is something, it is one lease line connection, right? So that is your private cloud. So you have 10 offices. This is one common hub. And inside your private hub, nobody is everyone is prohibited other than your enterprise traffic. So only your branch office and head office traffic should traverse on the MPLS cloud. So nobody is allowed. This is something like a physical isolation from the internet. That is, nobody is allowed to, send and receive traffic in the MPLS cloud. So you're from XYZ company. But when it comes to SD-WAN, so we say SD-WAN is the next generation of MPLS. So how they optimizing the routes and how they are optimizing the connection, how they have taken to a next level, that is purely based on QoS. So with QoS, there are multiple factors that is applicable. So we are going to discuss about the key factors, what is most important and widely used in the SD-WAN boxes. And I'll tell you why QoS is important. So if I'm sending an IP packet here, if I send an IP packet, and if I'm not applying any QoS, so this is treated as a normal traffic. So the use case is being in MPLS. So it doesn't care, because only my traffic can traverse in my private cloud, MPLS cloud. Whereas in the SD-WAN, it is again, you got one lease line connection. This is your SD-WAN edge device. You have multiple sites. So this is your SD-WAN controller. And this is your branch location. So you got your VoIP phones. You got your PCs connected. You got your server. This is all backplane connections, right? So this is your SD-WAN controller. The logic is it builds a tunnel every site like this. You can think just something like VPN tunnels. And they use some kind of protocol. So the key thing is here. So where exactly the QoS fits in. So the SD-WAN now in the MPLS connection, you don't have something like application-based routing. So in most of our deployments, so I have seen, so since we migrated from MPLS to the SD-WAN, the higher degree of advantage is something you have moved everything from your on-premise to cloud. So you got your Office 365, your Teams, all your on-premise application before that's been completed, migrated. Now it's an AWS and all this, right? AWS, your Azure Cloud AD, Active Directory. It's all hosted in the cloud. So what exactly the SD-WAN is doing here? So based on the application-based routings, so based on the QoS, so if my traffic, this particular PC is sending a traffic to Teams. So in the SD-WAN box, I'm saying that the Teams traffic has higher precedence. The Teams traffic has a higher precedence over the other IP packets. So what happens, the priority is given here. And it only works when there is a congestion. So inside in your WAN link, there is a congestion. So if a PC is trying to make a Teams call, so for your voice traffic, it takes the precedence over the other traffic, and without any problem, your voice traffic is going to reach the destination, and without any interruptions and without any network performance issues, you will get back your calls and your calls goes very smoothly. So this is based on application-based routing, and they defined a QoS. How they're going to distinguish? That's the point. So if I send an IP packet, how exactly the SD-WAN box is going to distinguish this? Is it the voice-based traffic, or it is a normal IP packet? So that is something we write here. In the QoS, we define this is a Teams traffic. So we will discuss about that in detail, about what is differentiated service bit and what is TOS. So the key thing you should understand about is you can apply your QoS in two layers. One is in layer 2, we say it is COS, class of service. And in layer 3, it is type of service. So this can be applied. One typical way of doing is they will apply for VLAN specific. That's an implementation I have seen. You have maybe a higher degree of understanding to apply for other protocols, but most widely I have seen is they apply for VLAN class of service, and for layer 3 we say type of service. So the type of service is further, that's been the modern version of TOS, I would say, is differentiated services. We call this as DSCP bit. So in the IP header, we'll look at where exactly this DSCP bit and TOS fits in. But the takeaway here is, so when a traffic comes from voice traffic, so I'm going to differentiate. So I'm going to mark this example for just this. So this is for understanding purpose. So example, if my team's traffic is with red label. So here I'm going to specify in QoS my team's traffic, red label. So the higher the priority is. This is taking precedence over the other IP traffic here. And if I send a traffic from mission critical application, something like your telnet, because if there is a slow connection and my telnet should never be impacted. So I'm saying that my telnet has a tag of LO. And this a traffic coming from this LO tag, that is taking a precedent over the voice link, because even the voice link is degraded. I still have to have a connection to my box to check what exactly the problem is and where exactly the saturation happened or where is the bottleneck. And before applying this QoS, so the key consideration you have to do a very good design is the simplicity of design is something. When you design something, maybe if you got your 100 Mbps link here and you got your server, it is used for replication. And it is just maybe a 1 gig link. So this is a bottleneck here. So even though if you apply QoS, that is definitely that's going to take a precedence and that's going to differentiate my traffic and giving a priority to it. But on top of that, so if I have a server and if I'm replicating 1 TB of data, and somewhere it's a replication is happening somewhere here, something like that, and I got a server here. And here the replication happens between these two servers. So we definitely have a separate link for this. But what I'm saying is when it is traversing from the core switch to your SD-WAN box, or it can be any kind of your edge device. So it's always recommended based on the link speeds. So it can be a 10 gig. So apparently you see a better performance here. So you don't see any kind of packet loss if it is good, the link is good. So when you design something, it should be simple and we should follow the basic protocols of, so based on the amount of traffic you send and receive, you have to upgrade your links accordingly. So that would be helpful for you to avoid all this kind of network performance issue. This is one thing. So if I got 10 gig link and the point is where exactly I have to apply QoS. So here we comes for QoS pre-classified. There's multiple ways of doing QoS. The key factor what we are going to discuss today is QoS pre-classified. So what is that? So when a traffic, so this is a switch. So when a packet comes from a PC, so the QoS is applied. So once I receive this, right? The QoS is applied based on the application. We discussed about that. So, but what the QoS pre-classify does, so before your encryption, example, if I am using a GRE tunnel over IPsec. So my QoS is applied before this GRE encryption. So this helps to remediate a lot of issues with GRE traffic. So pre-classify is something before treating the IP packet. So the QoS is applied. So I am safe if you look at my IP packet before my QoS. So I am good, and whatever the QoS policy that you are going to apply for this particular GRE tunnel, that's been applied before it interprets your IP packets. QoS, then it becomes an IP packet here. So it takes the precedence over the IP, all your IP packet. This is a very good advantage of having QoS pre-classify. So this is always recommended for every DMVPN connections. If you have multiple sites connected like this. And you have a DMVPN running. And it can be anything. I'm just giving an example. So here you use an EIGRP and you build the tunnels here. So if you apply a QoS pre-classify on your tunnels, the quality of tunnel looks really good. And whatever the issues you face with your QoS related, and it takes the precedence over the other traffic. And now let's discuss about the common, the default DSCP values that's been set for OSPF. So now let me open up the slide. It will help you to understand even more better. So if you look at this, so is there congestion on your network? So as I told you, your QoS will only be applied if there is a congestion. Otherwise, there is no priority. It just works like a normal traffic that's traversing between source and destination. So is there a congestion on your network or in your internet egress? Is the traffic going out? Yes, QoS DHCP will help you out with this. So is there a is there a congestion on your wireless network? Yes, QoS will be applied here. So are your LAN switch port set up to support QoS and respect app-based QoS DHCP marking has been done? You can mark your application something like this. So this is my voice traffic. So the DHCP value is 46. And if it is a routing, my DHCP value is 48. And since it's a video conferencing, 34. So you have to look at this TOS bits. This all DSCP comes under the layer 3. And the COS comes under the layer 2. So mostly people, they use DSCP, so layer 3. And based on this, you can make use of this header information. So whatever the DSCP value you see, that exactly matches your AF values here. So QoS definitely helps. So your wireless environment setup to support QoS and respect app-based QoS, you should do your DHCP marking in layer 3 header. See, if your LAN switch port setup to support QoS, no, then QoS will not help. So if you apply that, yes. Is your congestion happening? Yes, and your QoS will help you. If you're not applying your QoS, it will not help you out. So this is legacy old model of saying it's a TOS. It is in the IP header. Let me show you the IP header for you. Okay, here exactly the TOS fits in. It's an 8-bit value here, TOS. But in the Wireshark, you will see the differentiated service bit, that is DSCP value. You will see there in Wireshark. So from the IPv4 perspective, it is your type of service is 8 bits. You can see here the TOS is further classified into DSCP. So we got this DSCP IP precedence. The IP precedence is how I'm going to apply this QoS and how it is taking a precedence over the other traffic. So if I say it's a Teams, and if I mark the traffic with the appropriate values, whatever given for it, so I'm giving a precedence for the Teams traffic rather than all the IP traffic. So my precedence always goes for Teams traffic, then comes the next traffic here. So this is purely layer 3 TOS. So if you look at this in the IP packet, you see this TOS field here, TOS bit. And it is an 8-bit value, and the first 3-bit is a precedence. There you mark your traffic and based on the type of service you have. So this is a precedence number. So if it is all zeros, that is routine. And if it is marked with 001, it is a priority. So you don't want to much go deep dive about it. So the ideology is what is TOS bit and what is differentiated services and how the switch is going to look at it. So this is called the very important field you should see in the Wireshark is a code point. So that is per hop behavior. For every hop, this is applicable. The code is similar to precedence that we used in TOSbyte. It is used to set a certain priority for a traffic. So nothing we're going to discuss more about this. So the ideology is something how my QoS helps and what is DHCP and how exactly I can see that in Wireshark. So you can leverage your understanding with this, with the multiple implementation, multiple designs. So now let's go back to Wireshark. And I'll explain. So what kind of topology is this? I have built a simple topology. Let me open up this. So my fast Ethernet 0/0, I have assigned the IP address 192.168.34.3. And in router 2, if you look at this, show IP interface brief. So I've given 192.168.34.4, a point-to-point connection between this switch and the router. And both my line and protocol both are up. So my connection is good. So how I'm going to apply the policy. So I'm saying here, so by default, the key thing you have to know is the SYN wait time is 5 seconds. You can tweak your values. So based on the devices you use. So if I send a SYN and I'm not getting a reply back, it will wait for 5 seconds, sorry. And if you look at this ICMP, this is a class map. I have to use a class map on policy map. That's really going to define. So the class map, the policy map is the hierarchy and the class map comes below that. So class map, I am saying that match all your own predefined name you can give for your class map. And I'm saying this match access group 100. And I'll show you what is the access group 100 I've defined. Show IP access list. So I'm saying the traffic from 192.168.34.3. So between 192.168.34.3 and 34.4. So if you look at this, I have applied the service policy here. So this is a policy you have to bound to your egress always. So service policy outbound, and I've used a class name priority here. So run. So for my GRE tunnels, I have applied QoS pre-classify. That's something you have to treat my QoS before the IP precedence. I mean, before you look at the IP header, so I want my QoS to be applied before that. That's actually a very good way of doing your tunnel. So most of the time I have seen people, they apply QoS pre-classify for it. And I have applied in my tunnels. So before encryption, my QoS will be applied here. That's the meaning of QoS pre-classify. And if I want to check my config, show policy map, interface fast Ethernet 0/0, that is my egress. And you can see the class map, ICMP, and I can see 39 packets. This is all other packets. But whatever the IP that I have allowed in the access list, that's going to be applied for my QoS treatment here. So now let me generate a traffic, show IP access list. If you look at the values, it's 39 packet. And this packet is increasing for my class map. That is 44 packets. My tunnel is down. If I give debug tunnel on both ends, so now I'll generate a traffic here. So I have to ping the other end, the tunnel that is 24.4. It is tunnel is down. And let's start the capture. So it says OSPF multicast address I'm trying to reach. I'm going to bounce this tunnel. .4. If I ping the other end of GRE, it's 192.168.24.2. Going to this router. If is fast, sorry, not fast Ethernet 0/0, it's tunnel. Good, no shutdown. Interface tunnel 1 shut, no shut. So tunnel is up. So I cannot ping. So now let's go one by one. So let's see what is how I can differentiate how now Wireshark differentiates the traffic, the QoS traffic. So from the reachability perspective, let me ping show IP interface brief. To do a ping, I can ping. Where's my ICMP? Capture seems to be not working properly. So if I go back and do a ping, okay, I see the ICMP packets. So let's stop here. So if I look the ICMP packet, the DHCP value is a default 0. If you see, this is differentiated services field, and it is set to 0. And if I look at this OSPF, it says it is class selector 6. So the appropriate DHCP value is 46. Sorry, 48. The DHCP value is 48. So I can see the same in Wireshark here. The class selector is 48. If I go to ICMP, it is default 0. So what happens when there is a traffic, if it is an ICMP and if a traffic is for OSPF, that OSPF taking the precedence based on the marking, because I mark this traffic, it takes a precedence over the normal ICMP here. And the same way, if you apply for your DMVP and other stuff, and if you apply your pre-classify, you see the GRE tunnels and EHRP takes a precedence over it. So where is the key thing we have to look at is the differentiated service value you have to compare. So here it says CS6 and 48. And for every protocol and every traffic, there is a DHCP value. As I told you, for routing, it is 48. And we are doing this OSPF routing and it matches 48 here. So with a given link and how this congestion avoidance is happening, that's how the QoS helps you. And if you want to check is that your QoS is properly applied, so you have to do show interface, the respective interface. If you see, the queuing strategy used is QoS pre-classification. So it takes the precedence here. Show policy map. Interface tunnel 1. I haven't applied any policy in tunnel 1. Show policy interface fast Ethernet 0/0. It will show me I am matching the traffic only for ICMP. and it is not taking any precedence here. But when the OSPF packet's been exchanged, it's not even looking my QoS, but by default, the QoS has been marked. So when my packet, OSPF packet that's been egressing from my device to other remote device, so that's been marked with TSCP value 48. So this is how you can do it. So it's simple lab. So this is a configuration I have for this pre-QoS. So example, you work for Tata service provider and you are offering connections to customer with QoS guarantee. Once your customer wants you to create a tunnel interface, but they're also using a number of application that requires a low latency. Can we see how we can build a connection? So your application and everything that comes on the layer 7. So how I am going to, give guaranteed QoS for my connection. So you have to apply a policy. The same thing what I did is I have to apply a service policy on the router with the priority on for only for ICMP traffic here. This is for demonstration, so we are not doing much, but the takeaways where exactly it should be applied. So the QoS pre-classify is applied on the tunnel interface for the better application response, better performance for your applications. And also for testing, we applied the ICMP policy for QoS. So this is about QoS and what is the use of QoS. And if you see most implementation in the Junos boxes, they will use precedence value, that is a DHCP bit, to allow prioritization of OSPF messages or control plane traffic. The Junos sets all the OSPF packet to precedence 110 or CS6. And the same thing we have seen, we also Cisco boxes, they use CS6 for it. This is default. And with this link, you can do a deep dive about how the other classification and marking works. So the DHCP is advanced version of TOS. And we have seen how we can, the Wireshark is interpreting the values here. And there is an option for GNS. I'm trying to find hard time in fixing this, but ostinato with Wireshark is something you can generate your traffic in Wireshark. I think it has some bug, so I cannot run this. Let me stop this capture and try. Yeah, I haven't run my GNS VM. Let me go edit preferences, GNS VM. Let me turn on my GNS VM. So I think the memory is very less. Let's see, we can establish a connection with it. It's not working for my keystrokes. I'm waiting for, I think the device booted, but I don't see that here. Edit preferences, GNS VM. So my connection is up. Yeah. If I have to start this, I have to take a console. So right now I'm fixing this. So with this application, you can generate different types of QoS traffic. So you have to configure the streams to do it. It's very slow. I'm trying to fix this. So from this, if you have a connection to your switch and if you apply some QoS and you can actually test your connection, is it my DSCP values that's reflecting in the Wireshark? Whatever the config I apply for the specific, you see this goes down. So you can play around with this ostinato. So I'll give a documentation how exactly I have done this. So I'm going to shut down this connection. You go to ostinato traffic generator. For Wireshark. Yeah, we have to go to GNS3 marketplace. And here is the link. So there's no much instruction I have given. It's given here, but all you have to do is, this is pretty straightforward. Once you download this, you will get a template. Ostinato. This is my ostinato. It's my downloads. So edit file, import appliance. Okay, we'll do it and I'll download and do it. Again, so let me go back here. So we have to download this template. Okay, it is in OneDrive PCAP. So file, import appliance. I have to go here and I have to go to the template file, ostinato. I have to click on it and open. So it will say you have to install this in a GNS VM. So the template will be available in the guest category and finish. So it's already been used. If not, you can click finish. And you'll get your ostinato below this devices, the list of devices, PCs and firewalls. You'll get this ostinato Wireshark appliance here. Then it's pretty straightforward. You can add it. You have to, your GNS VM has to be powered on and you can drag and drop here and you can start and doing it. And it will use the VNC terminal. So from there, you can access it, and there is a very good document I saw here. So here you can go through the slides to use this particular tool, features and documents. I share this to everyone, chat. So you can play around with this, and I'll also try to fix it. So there you can generate multiple QoS traffics. When you apply based on the QoS policies, you can apply, you can generate the QoS traffics, and you can see the same in the appliances, whatever appliance you use, you can see that. And now let's jump into the other key features that is helpful in Wireshark. So let's see what is protocol hierarchy first. So if you go to statistics, the third option is protocol hierarchy. So if you see what are the protocols I'm running now, I'm running OSPF. I'm running my IPv4. If it is an IPv6, it's going to say IPv6, and the actual data is this. And I'm using the loopback adapters here, and I'm using OSPF. So if your CPU is consuming a lot in your boxes, and if you see what is the top protocol that's being used in your router, so you can take this dump cap and you can actually compare. So what is the amount of traffic that's been sent, this percentage. So 26% out of 100% is 26% my OSPF traffic is consuming, and 52% my internet protocol is consuming here. So you can also see here the data is just 21%. So here you can see your actual IP packets has been going back and forth, and your OSPF communication is really good and it is increasing. And you can see your ETH layer 2 information with the protocol hierarchy. So pretty handy to use it. So what kind of protocol? If you use GRE, it shows up GRE, and if you are using BGP, it's going to show it as a BGP and EIGRP. So you will have a bird's eye view of, okay, what are the protocols that's running on my appliance here. So the final thing is TCP flow graph. So you have to go to statistics again, and you have to click on flow graph. And if you look at this, the key thing you should look at is where the communication is happening is between 192.168.34.3 and 192.168.34.4. And it will show the same thing in the Wireshark where exactly your packet is. So here is your packet. It's highlighted in the background. So you see this is an ICMP ping request that is coming from 192.168.34.3, and that goes to 192.168.34.4. So I got a ping reply back with TTL. And if you see all this is this communication, it's a differentiation. This is one ICMP, full ICMP. For my ping request, I get a reply back. You can use the identifiers to classify the same. And if you look at this, so my appliance is sending a hello packet to all this OSPF multicast address. And the hello packet's been sent from this device 192.168.34.4 to the OSPF multicast address here. So in turn for this hello packet from 192.168.34.3, I receive the hello packet back. So I see hellos, and definitely OSPF is running on it. And if you want to limit to a display filter, whatever you apply there, it will be applied based on your display filter, whatever you want to apply there. If I want to apply only for this particular IP address, you can go to statistics, flow graph. You have to click on limit to display filter. So I see only the hello packets. So from 192.168.34.3, I send hello for this OSPF multicast address. And then the same, in turn, it sends an hello packet back. So you can also classify your TCP, UDP, TCP flows, ICMP flows. So there's no TCP flow. So yeah, I have given all flows, and any address is always recommended to use it. So this particular flow graph helps you to have a complete visual of, okay, where exactly my packet is traversing. Am I getting a ping reply back with more visual? And when we look for OSPF, it shows more details about OSPF. And if you use GRE and your other protocols, you'll get to know the complete insight of what exactly happening between source and destination. And if you click on a particular packet, it's actually highlighted back the Wireshark. So this is about TCP graph. Sorry, it's about flow graph. And you see the TTL values and everything's common we have seen. So you can make use of it when you do a troubleshooting.